So now we're going to be looking at some past questions that are relating to everything that we've learned so far, so we can see how to apply the concepts that we've learned. So in the first question, we are told to find the area of the figure above, and this is the figure over here. So I'm going to draw it out for those that cannot see it properly so you can see it clearly. So you have a shape like this, and you have this. And I told that the length here is 5 cm, distance from here to here, and the distance from here to here is 15 cm. Now we are told to calculate the area of this figure. So the first thing you want to do is you want to split this figure into two different parts. So the first part, I'm going to take out the semicircle that is on top. So I have this semicircle over here. And the second part, I'm going to take out the rectangle, and I have this rectangle over here. So now I can easily find the area of these two shapes and add it together to get the total area of this figure. So for this semicircle, I know that the area for finding the area of a circle is pi r squared. And since the area of a semicircle, or since a semicircle is half of a circle, I would need to divide my answer by 2. So the area of a semicircle is pi r squared divided by 2. Now I'm told to take part 22/7, so this becomes 22/7 times, and my radius in this case is going to be 2.5, because the diameter, the distance from here to here is the diameter, and it is 5. So half of it is going to be the radius, which is 2.5. So the radius is 2.5. So I have 2.5 squared over 2. And that becomes 22 times 2.5 squared is 6.25, and 7 times 2 is 14. And when you punch this into your calculator, you get 9.8. Now for the rectangle, that's pretty straightforward. I told that the length here is 15 and the breadth is 5. So the area is just going to be the length times the breadth, and that is equals to 5 times 15, and that gives us what? 75. So now we can say that the total area, the total area is equals to the area of the semicircle plus the area of the rectangle, and that will be equals to what? 9.8 plus 75, and that gives us 84.8, and the unit is centimeter squared since I'm dealing with area. So the correct option to this question is option B. Now to the next question. I told that the area of a square is 144 square centimeter. I told to find the length of the diagonal. So the first thing you want to do is try to sketch out your problem. So you are given a square, and this is the square, and I told that the area of this square is 144 cm squared. But now told to find the length of the diagonal. The diagonal is the line that runs from two opposite edges of a shape. So you have this line over here as the diagonal, and let me call it D. So the first thing we want to do is to find the length or the size of the square. So we can call it A, and since it's a square, all the sides are equal, so we label it as A. So the area of a square is given as A squared, and we have been told that the area is equals to 144. So my A will just be the square root of 144, which is equals to 12 centimeter. So the length of all the sides of the square is 12 cm, 12, 12, and 12. But we are asked to find the diagonal. So I'm going to bring out this triangle over here. So I have a triangle over here like this, and I know that the length here is 12, and the length at the base is also 12, and I'm told to find the length of the diagonal. So for my Pythagoras theorem, I can write that d squared is equals to 12 squared plus 12 squared, and I can write that d squared is equals to 12 squared is 144 and 12 squared is 144. So d squared gives me 288. So this is just the square root of 288. Now 288 I can write as the square root of 144 times 2, and I can write it as the square root of 144 times the square root of 2, and the square root of 144 is 12 times the square root of 2, which is square root of 2, then centimeter. So the correct option to this question, the length of the diagonal is 12 root 2. In the next question, I ask that in the figure above, PQST, sorry, this is a mistake, this is supposed to be PQST here, so I'll write it out. So PQST, that is PQST, is a parallelogram, and TSR. TSR is a straight line. This is a straight line over here. If the area of triangle QRS, if the area of triangle QRS is 20 centimeters square, find the area of the trapezoid PQRT. So we're told to find the area of this trapezoid PQRT. So I'm going to draw it out. So how about this trapezoid? To find the area of trapezoid PQRT. Now, since I'm told that this length here is a straight line, I know that the length of this line TR will be the length of this TS plus SR. And I know that TS is 10 and SR is 8. So the total length will be 10 plus 8, and that gives me 18. So the length of TR is 18. What about PQ? I'm told that PQST is a parallelogram. And what does that mean? It means that the opposite of the opposite sides are equal in length. And since I know that the length from TS is 10, then definitely length of PQ must also be 10. So the length here also is also 10. So the area of a trapezoid is given by what? Half into bracket A plus B times the height, where A and B are the lengths of the opposite side of the opposite parallel side. So in this case, A is 10 and B is 18. But I don't know my height. However, I'm told that if the area of the triangle QSR, so this triangle over here QRS, we have been told that the area is 20. So from this, I can try to find the height of the triangle, and let me bring that out. So I have the triangle over here, and I have what? Q, R and S here, and I'm told that the base is 8, and I can find the height. Now I know that the area of a triangle is given as half times base times height, and I've been told that the area of this triangle is 20, and the base is what? The base is 8, so times 8, and the height is h. So the height, when I cross multiply, so I have 8h is equals to 40. So if I divide both sides by 8, I have my height to be equals to 5 cm. So the height of this triangle is 5 cm, and therefore the height of this trapezoid will also be what? 5 cm. So now I can calculate the area. So the area now is just going to be equals to half into bracket, the value of A is 10 and the value of B is 18, then my height is 5. So that becomes half times 10 plus 18 is 28 times 5. So 2 goes here 1, and 2 in 28 gives me 14, and 14 times 5 gives me 70. So the area of the trapezoid is 70 centimeters square, and that makes the correct option option B. In the next question, we are told that a circle of perimeter 28 cm is opened to form a square. So we have a circle, and the perimeter of the circle, or the circumference, is same thing as the perimeter of a circle, so that the circumference of the perimeter is 28 cm. That is the length of all these sides. What is the maximum possible area of the square? So what we are going to do now is try to find, since we already know the length, we'll try to figure out what the length of the square should be. So we can write out that the perimeter of the circle must be equal to the perimeter of the square also. So now the perimeter of the circle I've been told is equal to 28, and the perimeter of the square I can write that as 4L. That's the formula, where L is the length of one of the sides. So if I divide both sides by 4, I have L to be equal to 7. So that means the perimeter or the sides of the square must be equal to what? 7. So I have 7 in all the sides as shown like this. So the perimeter is 28. So the area of this square is going to be what? 7 times 7, and that is equal to what? 49 centimeters squared. So the correct option is option B. Here we are told that an arc of a circle subtends an angle of 30 degrees on the circumference of a circle of radius 21. Find the length of the arc. So I want you to really pay close attention to this question, because there is a little twist to it. So you have a circle and we have the arc, and let me just indicate the arc with this red marker. So we have the arc over here, and we are told that, so this will be the center of the circle. Now we are told that it subtends an angle not at the center but on the circumference of the circle. So that means that when we draw a straight line towards the circumference of the circle like this, and we draw it like this, the angle subtended over here is what? Is 30 degrees. So you have to take note, the angle is subtended on the circumference of the circle and not on the center. Now the radius of the circle we have been told to be 21. So if the radius is a line drawn from the center of the circle to the circumference, so these two lines over here are the radius, and we are told that the length is what? 21. So the length of this line from here to here is 21. Now we are told to find the length of this arc. So this angle here I can call theta. If you remember the formula for our arc, find the length of our arc, we say the length of arc or arc length is equals to theta over 360 times 2 pi r. Now if you recall, what is the value of theta? Theta is the angle subtended at the center of the circle. But in this question, we are not giving the angles subtended in the center. Instead, we are giving the angle subtended on the circumference of the circle. So if you recall from our circle theorem, we said that, and if you don't know that, you should try to look through that. We said that the angle subtended at the center of a circle is twice of the angle subtended at the circumference of the circle. So therefore we can easily figure out the value of theta. So therefore theta will just be equals to 2 times of the angle subtended at the circumference, and that will be 2 times 30. If you don't understand what is being done, I suggest that you go through the section on circle theorem. It's really important for this question. So now I can calculate the arc length. I know that theta now is what? 60 over 360 times 2. I'm told to take my pi value as 22 over 7. And I'm told to take my radius. So my radius is given as 21. When I multiply or I punch this through my calculator, I get my arc length to be equals to what? Equals to 22 centimeter. So the correct answer to this question is option B, 22 centimeter. Let's move on to the next question. And here we are told that a chord subtends an angle of 60 degrees at the center of a circle of radius 14. Find the length of a chord. So this one is pretty straightforward. So we have a circle and we have a chord. Let me indicate that with an. So we have a chord. And we're told that and this is the center of the circle. And we're told that the angle that the chord subtends at the center, so this is already at the center, is given as what? Is 60 degrees. And we're told to find the length of the chord. So if you recall, the first step towards finding the length of the chord is that we drew a line down like this. So we have a vertical line, or we bisected this angle. So here will be equals to 30, and here also will be equals to 13. And the radius is given as 14 and 48. So we took one part out, so we have something like this, in which the radius is 14. Here is a right angle, and the angle here is 30. I want to find this length over here, so we'll call it x. So we can write that sin 30 is equals to opposite of hypotenuse. In this case, will be x over 14. So x is equals to 14 sin 30, and sin 30 is half. That will be 14 times half, and that is equals to 7. So the length of this section over here is what? 7 cm. So if the length of this section over here is 7 cm, we know that the length of this section here will also be 7 cm because they are congruent triangles, they are the same triangles. So we just add the lengths together. So we have 7 plus 7. So the total length of the chord over here is going to be, so the chord length is going to be 7 plus 7, and that gives us what? 14 centimeter. So the correct option is option B, 14 centimeter. Now we are told that an arc of a circle subtends an angle of 70 degrees at the center. If the radius of the circle is 6 centimeter, calculate the area of the sector subtended by the given angle. So we start by drawing it or sketching out the question. So we have a circle, and we are told that an arc subtends an angle of 70 degrees. So now let's take a section to represent our arc. So this is our arc over here, indicated by this red line. And we are told that it subtends an angle of 70 degrees at the center of the circle. So the angle subtended there is what? 70 degrees. Now we are told that if the radius of the circle is 6, so the radius are what, 6, we should calculate the area of the sector. So the sector in this case is this shaded portion over here, or all this area over here, or this portion shaded by blue pen. So we know that our formula for calculate the area of a sector, so the area of a sector is given as what, theta over 360 times pi r squared. So in this case, theta is straightforward, and that is 70 over 360 times, and let's take pi as 20 over 7 since we are not given, and our radius is 6 squared. So that will be what, 70 times 22 times 6 squared is 36 over 360 times 7. And when you punch it into your calculator, you get the value of your area to be equal to 22 centimeters squared. So the correct option to this question is option A. In the next question now, we are told that x, y, z is a circle with center O and radius 7. Find the area of the shaded region. So for those that can't see it clearly, I'm going to draw it out again. So you have the center over here, and you have a segment over here. So you have line drawn towards the center, and you have line drawn also towards the circumference. This is similar to one of the questions that were solved before. So we have about 45 degrees here. This is the center, and I'm told that the radius is 7. So now I need to find the angle here, theta. I know that theta in this case, the angle at the center is twice of the angle subtended at the circumference. So my theta in this case is just going to be what, 45 times 2, and that's equals to 90 degrees. So the angle here is 90 degrees. The question asked me to calculate the area of this shaded region, and as you can see, this is a segment over here. So I'm told to calculate the area of this segment. If you will recall, area of a segment is given as what? The area of a segment is given as r squared into bracket pi theta over 360 minus sine theta over 2. So what does that become? My radius is given as 7 squared into bracket, my pi is 22 over 7 times my theta is 90, then over 360, then minus sine 90 over 2. So what does that become? 7 squared is 49 into bracket. When you punch it into your calculator, you get 0.7857, and sine 90 is 1, so 1 divided by 2 is half, which is something as 0.5. And when you subtract, you have 49 into bracket 0.2857, and when you multiply these two together, you get 14 centimeters squared. So the area of this shaded region over here is 14 cm squared, and the correct option is option D. In the next question, we are told that the volume of a hemispherical bowl is this. We are now told to find its radius. So an hemisphere, as you know, is half of a sphere. So it looks something like this. So don't mind my diagram. I'm just going to try to draw a rough sketch. So you have kind of like an hemispherical bowl. So now we know that the volume of an hemisphere is what? 4 over 3 pi r cubed. So for an hemispherical now, or for an hemisphere, or a sphere, is 4 over 3 pi r cubed. So since an hemisphere is half of a sphere, we just divide by 2. So 4 here goes 1 and 4 here is 2. So the volume of our hemisphere is what? 2 over 3 pi r cubed. Now we are given the volume, we are also told to find the radius. So this is pretty straightforward. So the volume we are told is what? 7182 over 3. And when you convert this to proper fraction, you get that to be 2156 over 3. So we can substitute. So I can write that 2156 over 3 is equals to 2 over 3. My pi value is 22 over 7, then times r cubed. When I cross multiply, I have 2 times 22 times 3 times r cubed is equals to 2156 times 3 times 7. Then I can divide both sides by 2 times 22 times 3. If I divide this side by 2 times 22 times 3, this cancel this, I'm left with what? And 3 cancel 3, I'm left with r cubed. And when you punch this into your calculator, you get 343. So R will just be equal to what? The cubic root of 343, and that gives you 7 centimeter. So the radius of this hemispherical bowl is seen 7 centimeter. The next question now, we are told that what is the volume of the regular three-dimensional figure drawn. So now if you see this figure, and I'm going to quickly try to just kind of sketch it out, but don't mind my diagram. It might not look perfect, but manage it. So we have something like this. Yes. So we are given that the length of here is 4. The length of this slant line over here is 5, and the length of this place over here is 8. We are told to find the volume. Now to find the volume, if you think about this, it looks like a cuboid, only that it is half of a cuboid. Now what do I mean by that? Let's quickly just draw a cuboid. So if you have a cuboid, normally you are going to have something like this, and you're going to have something like this. But now it's like having a cuboid now and dividing that cuboid into 2 along the diagonal of the cuboid. So when I divide this cuboid into 2 along its diagonal, I get something like this. So the volume of this figure over here is equivalent to having the volume of a cuboid, but divided by 2, because this is half of a cuboid. So now I need to find the formula for calculating the volume of a cuboid is given as what? The length times the breadth times the height. So what I have to do is to find this volume, then I have to divide it by 2. But now I know what the length is. The length is 8. I know what the breadth is. The breadth is 4. But I don't know what the height over here is. Instead, I know what the slant length is over here. I know that the diagonal over here, the length of it is 5. So I can bring out that triangle outside. And when I bring it out, this triangle right, I'm going to highlight with the red marker. I have something like this. And I know that the slant here is 5 and the base here is 4. So I can find the height. So based on Pythagoras theorem, I know that what h squared is going to be equal to the hypotenuse squared, which is 5 squared, minus this length over here, which is 4 squared. And that will be 25 minus 16. So my h squared is equals to 9. My h is equal to the square root of 9, and that is equals to 3. So the height over here is what? 3. So the height here is 3. So I know my length now, my breadth, and my height. So the volume of this shape will be my length and breadth and my height, then divided, which is the length of a cuboid, then divided by 2, since it is half of a cuboid. And what does that give me? My length is 8, my breadth is 4, and my height is 3. Then I have to divide that by 2. So 2 here, 1, 2 in 8, 4. 4 times 4, 16, and 16 times 3 gives me 48 centimeter cube. So the correct option to this question is option B. Now this is the last question that we are going to be looking at. And we are told that a solid metal cube of 3 cm is placed in a rectangular tank of dimensions 3 by 4 and 5 cm. What is the volume of what volume of water can it hold now? So you have like a container, and I'm going to just try to sketch it out. So you have like a rectangular tank, something like this. And now inside the rectangular tank, we know that the length is 3, breadth is 4, and the height is 5. So inside it, we now add a solid metal cube. So now inside this container over here, there is a metal cube. We have a metal cube, something of this sort. And the length of the side is what? 3. So all the sides are what? 3 centimeter. So now we're now told that when this cube is inside this container, what volume of water can it hold? So normally, without this cube inside, the volume of water that this rectangular container can hold is just the volume of this container. But now that there's already a metal cube inside that is already occupying space, so what we have to do is to calculate the volume that this metal cube is occupying and minus it from the volume of the full tank, the rectangular tank. Then the difference gives us the volume that is now available for the water to be held in. So now the volume of water is equals to what? The volume of the rectangular tank minus the volume of the metal cube. Now the volume of the rectangular tank, that is pretty straightforward. The volume of a rectangular tank is length times breadth times height, and the volume of a metal cube or a cube is what? The length cube. So what would that be? The length of the rectangular tank, that would be what? 3, the breadth is 4 and the height is 5, then minus the size of the metal cube is 3 and that will be cubed. 3 times 4 times 5 gives me 60, and y 3 cube gives me 27, and 60 minus 27 gives me 33, and the unit is what? Centimeter cube. So the volume that is now available for water to be held in this rectangular cube is 33 cm cube. So that gives the correct option as option B. So what I will advise for you to do now is to try to go through the exercises and try to solve the questions that have been given, and also you can look through the past question and try to check out more questions and try to solve them. And if you have any difficulty, make sure you use the forum so that you can relate with other students and help each other learn. So that will be all for now. Bye.